Traditional views of causal inference emphasize that correlation does not imply causation, and that causal relationships can only be established through manipulation and true experimental designs. Under this perspective, observational data are seen as fundamentally insufficient for making causal claims. Modern causal inference challenges this position by providing a formal framework that integrates causal reasoning with statistical analysis, allowing researchers to draw causal conclusions from observational data under clearly stated assumptions. A central figure in modern causal inference is Judea Pearl, who argued that understanding causality requires moving beyond associations to reasoning about what would happen under hypothetical changes, known as counterfactuals. A key tool for formalizing and analyzing these counterfactual relationships is the directed acyclic graph, or DAG for short. DAGs are causal diagrams that represent relationships among variables and allow researchers to explicitly encode assumptions, guiding data analysis and supporting valid causal inference. Within DAGs, three fundamental three-variable structures serve as building blocks: the fork, the chain, and the collider. In a fork structure, one variable, say x2, acts as a confounder, or a common cause, that induces a non-causal association between x1 and x3. In a fork structure, conditioning on x2 blocks the non-causal association between x1 and x3. In a chain structure, one variable, say x2, is a mediator transmitting the causal effect from x1 to x3. In a chain structure, conditioning on x2 blocks the indirect causal path between x1 and x3. In a collider structure, one variable, say x2, is the common effect of x1 and x3. In a collider structure, the collider naturally blocks the non-causal association between x1 and x3, so they are initially independent. However, conditioning on x2, a non-causal association between x1 and x3 will be unblocked, a phenomenon known as a collider bias. Together, these three types of DAGs determine how associations arise and whether controlling for a variable clarifies or distorts causal relationships.